You can use logical functions to ask yes or no questions about your data. If the function returns yes as its answer, then you can direct Excel to perform the required action. However, if the function returns an answer of no, then Excel can be directed to perform a different action. For example, you can direct AdventureWorks' if function formula to ask the question, has this salesperson met their target? If the answer is yes, then they'll be awarded their bonus. If the answer is no, then they're not awarded a bonus. For these tests to work, the formula must contain logical operators. The logical operators determine what kind of question the formula is asking and what value it needs for its answer. For example, a formula that tests if 1 equals 1 would return the value of true. An Excel formula that performed the logical tests 2 is greater than 1 and 1 is less than 2 would return an answer of true for both tests. Let's take a formula where Excel checks to see if the value in cell D2 is the same as or larger than the value of 400. If even one of these arguments were true, then the test would return the value of true. For example, the result of the logical test 1 is not equal to 2 would be true because the two numbers are different values. The first piece of information is called the logical test. For the logical test, you need to identify the cell that contains the value to be checked. You also need to specify the test to be carried out in relation to this value. This is the if keyword followed by parentheses. It's within these parentheses that you must type the logical test. For example, Lucas needs Excel to check the total sales of each team member to determine if they meet their monthly target. In Lucas's case, if his test returns a value of true, then the team member is awarded a bonus. If Lucas's test returns a value of false for a team member, then Excel returns a value of 0. In other words, that person is not awarded a bonus. The dataset Lucas requires is in a workbook called Monthly Sales. The workbook contains 4 sheets, one for each sales team. For this exercise, let's just focus on the results for Team A. The worksheet lists the name of each team member, their total monthly sales, and their monthly target. The bonus amounts must be calculated and listed within column E. Any team member who meets or exceeds their target is awarded the bonus figure in cell H4. Let's begin by finding out if team member Michelle Cook is entitled to a bonus. Position the cursor on cell E4. Type an equal sign, the keyword if, and an opening parentheses. You need to place your arguments for the if function within parentheses. Notice the floating help message prompting you for the 3 arguments that the function needs. Select cell C4 for Michelle's monthly sales data. Type a greater than symbol followed by an equal sign, then select cell D4 and type a comma. This instructs Excel to check if Michelle's sales figures for this month are greater than or equal to her assigned target. However, as you can see from the bold prompt text, the formula is still incomplete. You now need to instruct Excel on what bonus value to award. You must also include what action Excel should take if the result of the logical test is true or yes, and what to do if the result is false or no. Select cell H4 for the value if true. Add a $sign before the column initial and the row number. This $sign prevents Excel from adjusting it when copied. Then type a comma followed by a 0 for the value if false. This 0 indicates that Michelle doesn't receive a bonus if Excel doesn't return the required value. Finally, type a closing parentheses to end your arguments. Press Enter to execute the if function formula. The results show that Michelle has met her sales target and has earned a bonus of $500 for this month. Copy the formula down the column and execute it to determine how the other team members have performed. The results show that 3 team members met their sales targets and could be awarded a bonus. 2 team members did not reach their targets, so should not receive a bonus. Nesting functions is the technique of adding another function to the formula as an argument for the original function. In other words, you can place one function inside another to expand its functionality. The formula begins with an if that performs an initial logic test. If the test turns out to be true, then the formula will simply process whatever action is specified in the value if true argument. However, the result of the logical test could also be false. If so, then another if function in the value of false argument could run another test and process different actions. For example, a nested if formula could check if a member of the Adventure Work sales team meets a specific bonus band. If the result is false, then a second argument could check the value against another band, and so on. The ifs function steps through the tests, checking each one. If a test is false, it continues to move through the tests until it finds one that is true. When a logical test returns true as a result, the formula performs or displays whatever is in the value if true for that test. It then stops running tests. In the case of AdventureWorks, the ifs function can continually check each sales team member's sales results against the different bonus bands until it identifies a suitable amount to award them. The sales datasets are contained in the Team B worksheet in a workbook called Monthly Sales Figures. The Team B worksheet lists the names of each team member and their monthly sales result. It also lists their sales targets and the amount they achieved above their targets. The bonus amounts must be listed in column F, using the bonus bands data in column I and J. AdventureWorks also needs a formula in F3 that checks the sales data in cell E3. It must then calculate which bonus band is applicable to the team member Olivia King and display the correct bonus amount. Let's begin by typing the formula. Position the cursor on F3. Type an equal sign, an if, and an opening parenthesis. Next, select E3 to add that cell as the cell reference. Then type a greater than symbol, followed by an equal sign. Type 20,000, which is the first bonus band, and then a comma. Finally, select cell J3 to add it as the value if true argument. Then type a comma. This first part of the formula provides Excel with the following instruction. If the figure in cell E3 is greater than or equal to 20,000, then the staff member is owed the bonus amount in cell J3. But what if one or more of the amounts in column E are less than 20,000? If the amount in E3 is less than 20,000, there are still two other bands from which a bonus can be assigned. To test for these bands, you need to add another if function as the value if false argument in the formula. You can nest this function within the first one. First, type an if. In this instance, you don't need another equal sign. Then type an opening parentheses so you can begin writing your arguments. This second occurrence of the if will need its own opening and closing parentheses. The parentheses must contain three arguments: a logical test, a value if true, and a value if false. Let's create the logical test first. Select E3 to assign it to your argument. Then type a greater than symbol and an equal sign. Then type 10,000 and add a comma. Next, you need to assign the value if true. So if the amount in E3 is over 10,000, then the bonus amount awarded will be the value in J4. Select cell J4 and type a comma to assign it to your argument. Finally, you need the value if false. If it's not true that the amount is over 10,000, then the bonus amount awarded will be the value in J5. Select cell J5 to assign it to your argument. Each instance of if also needs its own closing parentheses. Type two closing parentheses and press enter to execute the function. The results of your function show that the logical test for the first if failed. So Excel moved on to the second if. The second logical test was true. So Excel correctly displayed the bonus amount of $1,000 in cell J4. Changing the monthly sales figure for Olivia to $67,140 would change the result in F3 because both if functions would have returned a false result. So the result would have been the value in cell J5. This formula is now a nested formula because there is a second if inside the first one. Let's delete this result and recreate the formula using the ifs function. When you type equals, an ifs and an opening parentheses, Excel only provides prompts for two arguments: a logical test and a value if true. As you learned earlier, you can use ifs to specify a series of tests and the value if true for each one. Let's step through this process. Select cell E3, then type a greater than symbol, an equal sign, and a value of 20,000. Type a comma and then select J3 as the band to be assigned if the first test is met. When you type a comma, prompts appear for another logical test and a value if true. For the second logical test, select E3 again. This time you must follow it with a greater than sign and an equal sign. Then select J4. Now you need to tell Excel that the final value if true should be the result of the formula. So type true and a comma, then select J5. Adding the word true here prevents Excel from producing a #NA error message. You also need to add $signs to the J3, J4 and J5 references. You can now copy this formula down through the column to calculate the bonus amount for each team member.